Okay, in this video I'm going to go over very briefly and quickly what exactly one has to do to start the CNC machine using the small Windows 10 minimal resource 15-inch laptop there. So pretty simply, all one has to do is come over here and plug in this USB printer port cable to the control board, and the other end of the USB cable into the only other USB port available on this laptop, because the mouse is plugged into the other one. So that's all you need. And then plug in the power cable so that it has power, and that incidentally will fire up the drives. I do not have drive enable switches on here right now, so if there's no voltage on the drives enable, they're just default on all the time. So pretty much if I grab this coupling and try to turn it, I can't, because the stepper is locked. And by the way, it's running very cool. I could leave these on all night setting still, because I have them tuned to 12,800 pulses and about 1.42 amps each for their maximum amperage. And that is all these need, because your ball screws give you all the torque you could ever want for a 3-axis CNC table this size. And by micro-stepping it to those high pulses, since I'm doing linear inches and we're using 5mm per revolution ball screws that are 16mm diameter, C7, 0 backlash pretty much, we set those to 5.08 revolutions to travel 1 linear inch. So if you take 5.08 times 12,800 pulses, you get some 64,000 pulses per linear inch. So that micro-stepping breaks it up pretty accurately. It does not miss steps, and you can achieve rapid traverse or travel on linear X and Y up to 90 inches a minute and 70 inches a minute per linear travel on each axis. I think I have the Z turned down to 50 inches because it's only 4 inches of travel, and I felt like 70 was a little bit too fast, since I only have a homing switch at the top here. So with that plugged in and powered up, all we have to do is come over here to the laptop, and if and when I decide to sell this, all you have to do is click in this box right here and simply type in Mach 3, and the Mach 3 loader comes in. Right click on that and run it as administrator, please. Now I think it'll work if you don't, but this is just a habit for me since Windows 10 came out. All of its annoying security attributes that it has running in the background nonstop. And trust me, you don't want Windows Defender running with the Mach software, so disable that. And it is disabled on this system right now. So you select the smooth stepper, set up, and hit OK. That opens the Mach 3 software. Then this message will come up and ask you which device you want. Well, there's only one. Normal printer port? Absolutely not. We're using a smooth stepper control port card, 100 kilohertz, so we can generate pulses up to 100 kilohertz per second per axis. So you'll select the BSM Motion version 2, hit OK, and then simply come down here and select reset, and now the system is ready to run. So your y-axis is on the up and down arrows. Your horizontal left and right arrows are for the x-axis that the 2 horsepower router is mounted on. I'm going to push the right arrow now, and you'll see it's moving across at approximately 70.65 inches a minute. And that travel is a maximum of 15.5 inches that way. Now let's move the y-axis by pushing the up arrow. The up arrow pushes it away from us. It's more, we're sitting behind the table right now, so let's move that one. And you can see that axis moving not as well because of the angle I'm sitting at. And of course that axis also is configured to 70 inches a minute. Okay, so I moved that out a little bit. Now I'll move the Z-axis down at about 50 inches a minute. You can see that is more than fast enough because it only has 4 inches of travel and it's already managed to go nearly 3 inches in about 1.5 milliseconds or something like that. Anyway, so the Z is a little slower. It can be sped up, but it doesn't need to be. Okay, now we're out this far. So if we want to bring everything back to the home position, it's already been home, so all you have to do is hit go to 0. When you hit go to Z or go to 0, the entire machine will ref back to its original 0 point where it started, and all 3 axes will move to that point. So let's hit that and watch it do that. And that is running at about 89 inches a minute. And now it's picking the Z up last, which I don't like. I need to change that. Should have picked the Z up first, in my opinion. Okay, so that's all you do. Now we're back at ref 0. So the next thing, let's go ahead and load a shape file I have in here. So if you come down here on the button, you select load G-code. It's going to go to the most recent folder I had. Down here at the bottom I have Shapes 3. Tap. I have some other ones too that I've already cut on previous videos, but this is actually Shapes 3. So let's open that up. And what that is, if I hit Regen Toolpath here, Regen Toolpath, it's cutting out 4 circles and 2 rectangles. And that was for the purpose of miking or measuring those after it got done to see how close the machine is right now, because we have not fully calibrated the machine yet. All right, once you've done that, you can see that basically what's going to happen is we're going to come in and pick the Z up 1 inch. So where the Z's at right now, if you look at it, we're almost to the limit switch up there on the top. Right there, okay? Right there is focusing on my finger. So what we're going to do is use the page down key. And we're doing this as if we're touching the tool to the top of our material, right? So we're just going to fake like we did. Now we came down 1.25 inches. So with the machine coordinates turned off, so if it's on, that's got a highlight red ring around it. We want to turn that off. And we're going to make that our material top, basically. So this is 0, that is Z. I'm going to hit Regen Toolpath. And then we're going to come over here to rewind G-code. Just to be safe, rewind your G-code, regen the toolpath before you start. And make sure you are at your 0 point where you want to start, which we are. We're going to start here and move out away in the positive direction on both the X and the Y to achieve cutting those shapes. So the only thing left to do now is just hit cycle start. Now you'll notice that I have this feeding at 65 inches a minute. Our maximum feed rate setting right now on Rapid Traverse is about 70.64. So 65 is probably a little fast for most things. Just depends what you're cutting and what size cutter you're using and the depth of cut and so forth, and I'll get into that on another video. But let's hit cycle start and just watch and listen to how the machine performs. So to pick up the Z 1 inches, and generally I would come over here and flip the router on before I even started that, but since we're just cutting air right now, watching the machine perform, that's what we're going to do. Going to zip over and cut the next circle. And it's hard to pick up on the video, even at 70 or 65 inches a minute. It's just, if I hold it still and get it to a good enough angle, I think you can see everything moving for the most part. And you can certainly hear the stepper motors moving in the background. They're quite smooth. Now what you hear making the most noise right now is the misalignment on the y-axis coupling. Now it's cutting out the rectangles. If we come back over here and look at the toolpath, so if you click on your toolpath tab, right here, you get a little bigger screen, and you can see it's cutting that circle right now. And it's going to move over and cut that circle next. And there it goes. Now remember, this is 12,800 pulses per revolution times 5.08. So this thing's having no trouble. Now it's actually just went back to its home position. So when it finished that, everything went home. So you'll see the Z picked up to 1 above. And if I go back to program run, I can actually, once again, hit go to 0, and it's going to move that Z down to what it thinks is the top of the material. And let's hit rewind the G code. It's actually already rewound. And let's hit regen toolpath. And then let's hit cycle start again and watch this one more time. Alright, cycle start. Picks up the Z. Moves to first cut, lowers the Z. And now it's cutting the circle. Pick the Z up, move to the next circle, lower the Z, plunge the cutter in, cut the circle, and this is 65 inches a minute, which for stepper motors, open loop, is pretty darn good. You can get smooth performance like that, not miss steps. And I've already tested this on some particle board in a previous video, which you can go back and watch. I don't remember what I titled it, but it's there. Now it's cutting the rectangles once again. And you can see that down here on the toolpath. Now it's going to move over and cut a circle. Pick up the Z, move over, lower the Z, cut the circle. So now that these motors are in action, what do they feel like? They feel lukewarm to cool to the touch. And I've already left these on all night on this setup, and they feel just the same when you get up the next day and touch them. So setting your system on maximum amps and setting it on maximum voltage and feeling those drives down there getting hot, and feeling the motors are almost too hot to touch, that means your amps and voltages are way too high for your setup. And if you have to run them at that, that means you need to adjust your gantry and ball screws so that they turn easier. We want all the force of the stepper motors to go into cutting the part, not moving the gantry. Moving the gantry should be the easiest part. Anyway, I guess that concludes the video for basic open loop stepper control performance of the do-it-yourself CNC machine that I've been working on since July. Obviously not every day, but off and on between work. So stay tuned for more videos, and we'll have some parts built soon.